Chapter 6 is all about polynomial functions. We've done linear functions, absolute value functions, quadratic functions, and now we go on to polynomial functions. So you might remember from algebra that a monomial is expression with one term. So it can be a constant, it can have one variable, it could also have two variables too. This one just has one variable, but another monomial would be 7w y. It's still a monomial. It's still one term together. A polynomial is a sum of monomials. So polynomials have whole number exponents. You cannot have fractional exponents. So these are all whole numbers. You can also not have, because of their whole numbers, you also can't have something in the denominator like this. You can't have variables in the denominator because this would be x to the negative 3, and we know that you can't have negative exponents. They have to be whole numbers. The standard form of a polynomial is when they're in descending order by degree. So you're writing them from highest to lowest degree, and I'm also going to add that you need to combine like terms. So standard form, write it in highest to lowest degree and combine like terms. So make sure that you can follow this table, that you understand that if something has a degree of 0, it's a constant. Because technically you could write this 6 as 6 times x to the 0. Because we know that x to the 0 is 1. So this is just 6. But we don't really write x to the 0 because we already know it's 1. But this is a polynomial. 6 is a polynomial. There's one term in this example, so you should also be able to name a polynomial by the number of terms. So one term is called a monomial. Mono means one, the prefix. 2 terms is a binomial. 3 terms is a trinomial. And we don't really have names for 4 terms or more. We just call them polynomials. So if it has 5 terms, you'd still just call it a polynomial. So the first 3 have specific ones. So you have degree, constant, linear, quadratic has a second degree, cubic has a third degree, quartic has a fourth degree, quintic has a fifth degree. So here are some examples. Write each polynomial in standard form. So remember, we need to write it from highest to lowest degree and combine like terms. And then classify it by its degree and number of terms. So you're going to have, a polynomial is going to have 2 names. So I think of it as having a first name and a last name. So first name you can name by degree, last name, number of terms. So letter A, first I'm going to combine 4x minus 3x and get x plus 5. So x plus 5, let's first name it by the degree. So it's degree 1. So remember, degree 1, we call it a linear. And then there are 2 terms, so binomial. Remember, bi means 2. And then letter B, I'm going to combine like terms. So 3x cubes and 2x cubes makes 5x cubes. And just remember, you keep the exponents the same here. I'm not going to add the exponents together when I'm adding polynomials. Plus x squared minus 4x. So first I'm going to name it by the degree. So it's a third degree, so we call that a cubic. And it has 3 terms. 1, 2, 3 terms. So it's a cubic trinomial. And then the last one, 6 minus 2x to the 5th. This is going to be your leading term because it's the highest degree. It's degree 5. And this is a positive 6. This has 2 terms, and it has a 5th degree. So 5th degree is a quintic, so you're going to call it a quintic binomial. So we can use, just like we can use linear models, cubic quadratic models. We can also use cubic and other polynomial models. So just like you did linear regression, you're going to put this in your L1 and L2. So let's read the question. The table shows the data on the number of employees a small company had from 1975 to 2000. Find a cubic function, so this is new, to model the data. Use it to estimate the number of employees in 1998. Let 0 represent 1975. So what you're going to do is, if 0 is 1975, let's cross off 1975 and write 0. So 1980, therefore, would have to be 5. 1985 would have to be 10, and so on. Now you're going to go on your graphing calculator, and you're going to go to Stat, and then Edit. And you're going to put this in your L1 and this in your L2. Now remember, I'm always going to put the independent variable in my L1. And since the number of employees depends on the year, this time is going to be your L1. And then I'm going to put in my L2 these numbers right here. And I'm going to get a function by doing stat calc after I've already put my list in. So stat calc, what am I calculating? You're going to looking for now a cubic function. So it's cubic regression. So once you click on the cubic regression, you're going to have an A, which represents the coefficient of the x cubed term, a B, which represents the coefficient of the x squared term, a C, and a D, which is going to be your constant. So once you get out this function, once you write this function, you need to use it to estimate the number of employees in 1998. So you are not just going to plug in 1998 for x. You really have to think, if it's 1998, go back to your chart. So if 1975 is 0, 1998 has to be 23. So let x equal 23. Let x equals 23 and plug it in.